the delta maths or whatever, and if it wasn't all the way done when I checked it, I put it in for whatever was done and left a note basically on the minor name saying like, hey, if you finish this, I'll update it, send me an email when you finish or whatever. A lot of you guys did. I'll get to it. Just 4 teaches today. There hasn't been a lot of time to get to any of that stuff yet. But I'll keep the email unread in my inbox and I'll make sure I get to it. Everybody cool? Okay. Today, then, we're gonna start chapter 1. And chapter 1 is really like an Algebra 2 review chapter. So we did some geometry review. Now we're gonna do some Algebra 2 review. And in chapter 4, we're gonna kind of start digging our teeth into trigonometry. Okay. So section 1 is all about functions. And you guys were in Algebra 2 last semester. Algebra 2 is basically just all about functions, right? We studied all these different types of function types. Talked about functions probably a good deal. Give me some kind of a definition for a function. What is that? Anybody brave wants to take a guess? Got some vague notion?
Like y equals mx plus 3.
Okay, so like an equation is one way to represent a function.
Right.
And a linear equation that you've described there is a type of function. Yep. Yeah, so there's 2 sets. You have a set of inputs and a set of outputs. So like in general, the x's are inputs and the y's are outputs, right? And now there's a rule about how the pairing between the inputs and outputs has to occur. Do you remember how that has to work to be considered a function? All the inputs have to have an output, and they have to have only one output. So like, if you do f of 3, it can't give you 2 different answers, right? That's not a function. Is everybody okay with that? All right. So let's now maybe clean that up into a nice rigorous definition that we can use a little bit more. Let's just make it a little bit more rigorous. So a function from a set D, that's our inputs, to a set R, those are our outputs, is an assignment, or maybe you want to call it a rule, or a map, or a pairing, or whatever, such that every element in D is mapped uniquely to an element in R. So this set D, we call this the domain, and this set R we called the range. So there's kind of 2 parts to this function definition. All the things in the domain get used, and they only get paired to one thing from the range, right? Nothing gets to go to 2 different ranges. Everybody cool with that? So let's look at some examples. So back in your Algebra 2 class, you have talked about some different ways to represent a function. One of those ways was with something called a mapping diagram. So mapping diagram is just like a visual representation of a function. So the first circle there is my set D, and the little dots inside of the circle are the elements inside D. And then the circle labeled R is our range, and the little dots are the elements inside the range. And then my red lines here is my function f, or represent my function f. And we're just going to ask you guys, does this represent a function? Yeah, right? So if I look, everything in the domain is going somewhere, and they're only going to one place. That's good. Okay. Let's look at another example. How about this? Does this represent a function? What do you guys think? Yes is the correct answer. So again, we're looking, does everything in the domain go someplace? Do each of those things have only one destination? Yes. Does it matter that not everything in the range got used? No. Did it matter that some of the ranges got used more than once? No. The function, whether something's a function or not, is only about the domain. So that's really the only part that we care about. How about, is this a function? Say no, why not? Yeah, this guy didn't go anywhere, right? We got a domain that wasn't used. Okay, sure. Oh, I switched there. Is this a function? No, why not? Yeah, if I look at that first domain, it's going to two different places. You guys feel good so far? Relatively easy concept to deal with, right? But how often did we represent our functions with a mapping diagram in your Algebra 2 class? Almost never, right? So let's go on and talk about some other ways we could represent a function. Well, another way we might have represented a function was with a graph, right? So does this graph represent a function? Okay, Katerina, say yes. Why? What kind of line? Vertical line, yeah. So you can use what's called a vertical line test. And basically what you're doing is you're checking to see if I draw a vertical line, will that ever intersect the graph more than once? And you can see that pretty easily that no matter what kind of vertical, or no matter where you draw that vertical line, it's only going to hit that graph once. Everybody's cool? That's equivalent to just checking for like this specific x value that it's only pairing with one specific y value, right? If it you drew a vertical line intersected more than one point, that would be one x value that would go to more than one y value. So it's equivalent to checking that second part of our definition. Does that feel good? Let's do another. This one is usually pretty, students like doing these graph ones because it's pretty easy to check. This is a function. No, why not? Oh, okay. Now, does it matter that I could draw like this vertical line that does only intersect it once? That doesn't matter, right? As long as I can draw a line that does intersect it, all I need is one vertical line that hits the graph more than once to make it not a function. Everybody's cool? But this was probably also, did we represent functions as graphs in Algebra 2? Yeah, but probably not primarily, right? What was the primary way we represented a function? An equation. Good. So maybe we have something like y equals x squared plus 1 or something. Does this represent a function? Can you tell by looking at it? If you can't, what could you do to tell? Could graph it. That's a perfectly reasonable thing to do. Got to go reset my calculator for what we're doing here. So there's my graph. What do you think? You say it's a function, right? But you agree with that? I would say not enough information to say. Now, what you said, you say this is a function, but in saying that, you've made an assumption. What assumption did you make to say that this was a function? You assumed that the x's were the independent variables and the y's were the dependent variable, right? In other words, that the x's are from your domain and the y's are from your range, right? And that was kind of the convention that we've used in Algebra 2 class. Everybody kind of agree? But there's no reason why we couldn't have said y is the domain and x is the range, other than like that's kind of not what we do, right? There's nothing in the problem that says that specifically x has to be the independent variable and y has to be the dependent variable. Now, if we're saying is y a function of x, then the answer is yes, and you can use a vertical line test on that graph. That is true. But from the problem, there's no reason why we couldn't have said or thought x being a function of y. Is there a way that we could have written this equation to really be clear to the reader which is the independent, which is the dependent variable? Is there a different notation we could have used? There is. You've used it before. Instead of y equals, what else could have you written there? What? Somebody mumbled it. You'd write f of x, right? Right. Did we do this in algebra 2? Use f of x's instead of y's frequently. What's the advantage of the f of x? It tells us specifically that x is the independent variable and f of x is the dependent variable. We can see from the notation that f of x depends on x. It's explicit to us. If I don't use an f of x, we're left trying to assume that x is the independent variable and y is the dependent variable. And if we had used different letters, like if I just would have written a equals b squared plus 1, where it's not x and y that are kind of our conventional letters, like what do we do with that, right? So the f of x notation, this function notation, really saves us the trouble of wondering which one is the independent, which one is the dependent variables. Because if I had asked, is x a function of y, the answer here is no. Because if I say let y equal 1, x could have, y equals 2, x could be 1, or x could be negative 1, right? Because 1 squared is 1 and 1 plus 1 is 2. And negative 1 squared is 1 and 1 plus 1 is 2. So this would be one domain going to two separate ranges. Or if you wanted to create a graph of this, you would have ended up looking, you would have gotten something like this, which obviously fails a vertical line test. If I wanted to try to get this on my calculator, what have I had to do that? Well, I would have had to rearrange this equation so that the x was by itself. So I would have subtracted 1 from both sides and then square rooted both sides. When I square root both sides of an equation, what do I have to remember? When we square root both sides of an equation, what do we have to remember? Yes, there you go. Now, can I type a plus or minus into my calculator? Is there a plus or minus button on my calculator? There is not. So to graph this on my calculator, I would have had to do square root of x minus 1. And then I also would have had to do the square root of x plus 1. I'm sorry, no. Negative the square root of x minus 1. Excuse me. So I have one that's positive and one that's negative. And when I draw them both, oops, I put that in the wrong spot, didn't I? You can see that again, there's my picture. So this guy should have been over here. My apologies. Shifted in the wrong direction. Yeah. Okay. So the big takeaway is unless you're told which one is the independent, which one is the dependent variable, you would need to use function notation or indicate which is the independent, dependent variable to do a problem like this. Everybody's okay with that? So either one is okay, whether it's saying is y a function of x and then list the equation like this, or we could just say is f of x equal to x squared plus 1 a function. Either is going to be okay. They both convey the same information. But you would need to have that information to be able to answer this question, yes or no, because depending on which is the independent variable, we got two different answers, right? One was yes, one was no. Do you guys kind of see that? Let's do another. Now, what letter am I on? H now, huh? Oh, let's write it this way. So let's say we ask, is y a function of x? And then our equation is y squared plus x squared equals 1. What do you guys think here? We're specific, right? X is the independent variable, y is the dependent. What do you want to do to try to figure this out? Can we tell just by looking at it? If your answer is, I can't tell by looking at it, what should you do? Use your calculator to get a graph and look at the graph, right? If I can't tell by looking at it in this form, just change the form and do something else. Can I type this into my calculator as it's currently written?
No.
No, why not?
Because y needs to be by itself.
Y needs to be by itself. So what should I do?
So you substitute that x squared from both sides, then you get y squared equals negative x squared plus 1.
Oops. And then we square root both sides. Yep. So we're just going to get y by itself. We just have to do some little algebraing. When I square root both sides, what do I have to remember? Plus or minus. Everybody's okay? Let's hit graph. Maybe pick a little bit more appropriate of a window. Oops. What did we get? Circle. Is this a function? No. So just turn this into a graph, and the answer is no, because we failed the vertical line test. Everybody happy with that? You could have also done this numerically. So I could have picked a value for x and shown that I could get more than one value for y from it. Everybody's okay with that idea? So let's say I just pick x equals 0. So if I do that, I get y squared plus 0 squared equals 1. So y squared would be 1. We square root both sides. 2 y values. So no, because x equals 0 goes to y equals 1 and to y equals negative 1. Oh no! Do you have to do both of these? No. Is either one appropriate? Yeah. Bella.
I have a quick question. So
Yeah, dude.
you're graphing this equation, so plus or minus square How would you do
So I just put in the positive one and then the negative one in another line. So I need 2 lines to do it.
Oh, okay. I didn't know if there was like a special trick that you could use.
That's the easiest way to do it.
Okay. Thank you.
Yeah, of course. No problem, dude. What do you guys think? Have you noticed a pattern yet about whether something's a function or not? If you look at these equations, when we rearrange them to get the dependent variable by itself, and we get this plus or minus, okay, why are we jumping? I'm just going to throw my computer through the window right now. Right, like we got the plus or minus here. That wasn't a function. We got the plus or minus here. That wasn't a function. Seems like that plus or minus is going to be a problem when that shows up, right? It's a pretty good indicator. What do you guys think? It's okay? That's section 1.1. At that point, you could be able to do questions 1 through 4 from the problems. Section 1.2 is about domains and ranges. Do we recognize these 2 words from Algebra 2? It's my hope. Before we start talking about domains and ranges, though, I need to talk about something called interval notation. Do you guys recognize that phrase? You used interval notation last year in Algebra 2, I hope. What is interval notation describing? What did you use it to use? What did you use it to do last year in Algebra 2? You used it to describe your domains and ranges. That's where you would have used it. So what is an interval notation used, or what is an interval notation describing? What are domains and ranges? They are sets. Sets. So an interval notation describes a set. Can I describe any set with an interval notation? No. Only certain kinds of sets. What kind of sets can I use interval notation to describe? The answer is a continuous set. So if I want all the numbers between 2 and 3, I could use an interval to describe that. That's an infinite number of numbers. Right? You have like 2.01, 2.01, 2.01, 2.02, like lots of, like infinitely many decimals in between those, right? Now, as opposed to, say I wanted the set of whole numbers between 1 and 10. That is just the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That you would not use an interval to describe. You just use like your squiggly brackets on a set. Everybody okay with that? So if you're not talking about all the numbers in between 2 values, we'd use a different notation. But when we describe our domains and ranges, almost always it's going to be everything between a couple of values, right? go grab that door. It's about to get loud. Okay. Or maybe not. I don't know. Maybe it's not going to get louder all of a sudden. I think it does, right? This is the period where people have lunch in the middle of it. Okay. All right. So let's just look at some examples. We'll give us some sets, and we'll translate those sets into intervals. Okay. And then we'll worry about domain and range after that. Deal? Okay. So let's say we have the set of real numbers greater than 8. Oops. Greater than 8. When I say real numbers, what does that mean? So there's like 4 fundamental sets of numbers. There's like your integers, your positive and negative whole numbers. There's your rational numbers, anything that can be written as a fraction. There's the real numbers, anything that could be written as a decimal. And then there's the complex numbers. Those are the things that could be written as like a plus bi. Remember doing the i's last year? So those are like your 4 fundamental number sets that you guys would have been used before. So real numbers, we're just talking about anything that could be a decimal, which makes this like a continuous set, which means we can use an interval on it. Is that okay with why I put the real number there? What that means? Okay. So I think that in a case like this, before I write my interval, I think it's often helpful to kind of draw a picture on the number line. So I'm going to start with my number line. I always put 0 on there just as a reference. And then the other number I care about is 8. Everybody's good with y? Okay. So it says this is the set of real numbers greater than 8. Is 8 greater than 8? No. So at 8, we should use an open circle or closed circle. Do you guys remember from like pre-algebra? This would be open because 8 is not included. And then are the numbers that are greater than 8 to the left or to the right? To the right. Right? If you're looking at your number line, after 8, or to the right of 8 is like 9, 10, 11, 12. That's the way that we're going. So far, so good? Everybody happy? So this picture I've drawn is going to be the way I'm going to write my interval. So my interval is always going to be of the form the lower bound for my set, comma, the upper bound for my set. So what's the smallest number that I care about here? It's the 8. What's the biggest number I care about here? Yeah, like positive infinity. And you don't have to put the positive sign there. I choose to do that for clarity's sake. Everybody's okay with that? The last thing we need to do with our interval is indicate whether the endpoints, these upper and lower bounds, should be included in our set or not. So was 8 included? No, we used the open circle, right? So if the net number is not included, we use a parenthesis. My other bound is the positive infinity. Is positive infinity in a number? Is that something that like x can equal? No, it's not like a specific value, right? The infinities always get a parenthesis because they're not an actual number. They could never be like, nothing can ever equal infinity. Everybody's cool? So this would be the interval. Note that that looks a lot like a point. Context here matters. We know it's not a point because it's asking for a set. Let's do another. This time, let's say we're looking for the set of real numbers between -2 and 6 that includes 6. Well, go ahead and draw my number line. I'll put in the numbers that I care about. Everybody okay there? All right. So what's the first number I care about here? -2. Great. Very good. Is -2 included here? Does it say it's included? No. So should we assume it is? No. So that'll get the open circle. What's the next number I care about? 6. Is 6 included? Yes. So that'll get a filled in circle. And the numbers in between -2 and 6 are those ones. So this represents my interval. So far, so good? So the lower bound for this interval is at -2. The upper bound is at 6. Very good. Is -2 included? No, so it should get a parenthesis. Is 6 included? Yes. So if it's included, it gets a bracket. So there's my interval. What do you think? It's okay so far? Does this look familiar? I like drawing the number line also. I think that's can be quite helpful, especially early on. You guys like that? I'm a visual guy. I think pictures help. All right. Let's say the real numbers less than -3 or greater than or equal to 1. So I'll go ahead and draw my number line, put in the numbers that I care about. So it says the real number is less than -3. So what am I going to draw for that part? At -3, I'm going to put a open circle, and I'm going to draw my arrow going left or right? Left. Okay. And then it says, or greater than or equal to 1. So at 1, am I going to put, what do I draw at 1? Closed circle. And then the arrow is going right. Everybody's okay with this? Now the key word here since my arrows are going opposite directions like this, what's the key word here? Or. So that tells me I'm going to be able to write an interval for this piece, and then I'm going to write an interval for this piece, because numbers from either place would belong in this set, right? Everybody agree with that? If I say you can have chicken or pizza for lunch, if you're eating chicken, you should belong at my lunch. Or if you're eating pizza, you would belong at my lunch. Or if you're eating both, you'd belong at my lunch, right? Everybody kind of see what the or is saying there? Now, of course, in this situation, there's no numbers that are both less than -3 and greater than 0. There's just can be one or the other, but anyways. Okay. So for the yellow piece, how am I going to write that interval? What do I write? What's my lower bound? -infinity. And my upper bound is? -3. Everybody's okay?
Yeah.
Okay. For the -infinity, parenthesis or bracket? Parenthesis. And the -3, parenthesis or bracket? Parenthesis. Again, open circle or not included means parenthesis. For the green interval, what's my lower bound? 1. And my upper bound? Positive infinity. Does the 1 get a bracket or parenthesis? Bracket. Does the infinity get a bracket or parenthesis? Parenthesis. Everybody's okay? Now there's one more symbol here that we need because of the or. Does anybody remember what this symbol is? That's okay. It's the union symbol. It's like this U with no tail on it. The union symbol is basically the set operator for the word or. So if you're a member of this set, you could come from the interval -infinity, -3, or you could come from the set 1 to positive infinity. So for example, -6 belongs in this set because it's inside of the first interval. 18 would belong in this set because it's part of the second interval. 0 would not be part of this set because it's in neither interval. Is that okay? We're going to do one more example, and then we're going to talk about domains. Cool? Okay. How about the set of real numbers not equal to 5? Oh boy. This is kind of weird, right? Well, we're going to start the same way. Let's draw a number line. What's the number we care about here? 5. So should 5 get a open circle or closed circle? Open, because we want the things that are not 5. So 5 is the only thing that's not 5. So that gets an open circle. Now, where are the things that are not 5 live? Both directions, right? So the things less than 5 belong, and things greater than 5 belong. You guys cool with that? What word did I use there? We used or, right? things less than 5 or the things greater than 5. It's a hidden or problem. Oh no! That's okay though. So again, we're going to have 2 intervals. For the yellow interval, the lower bound is negative infinity. Thank you. And the upper bound is 5. Does the negative infinity get parenthesis or bracket? Parenthesis. Infinities always get parenthesis. Does the 5 get a parenthesis or bracket? Parenthesis, because the circle is not filled in. 5 is not a member of this set. Then we're going to have that union symbol. And then the green, the lower bound is 5. The upper bound is positive infinity. You could just write regular infinity, though that's fine too. I always like to put the positives on. Does the 5 get a parenthesis or bracket? Parenthesis, it sure better get the same thing it got in the first set, right? And the positive infinity gets a parenthesis. Everybody's cool with this? Does this bring back some kind of remember doing these things, making these intervals, what the symbols mean, how to format it? Should be okay. All right. So let's talk about domain now. So there's 2 types of domain. There's the implied domain, this comes from just the equation of the function. And then there's the relevant domain. To get that, we're going to use the equation and the context of the variables. Everybody okay with this? Okay, so recall a domain is the set of inputs that also have an output, right? So when we're looking for the domain of a function, what we're going to be looking for are values for x that don't have outputs. Numerically, what that means is they give you undefined when you try to do that calculation. Everybody okay with that idea? So at this point, you guys have seen 3 operations that can result in undefined, or that can give you an answer that's undefined. Does anybody remember any of these operations? What's one thing that you could do that gives you undefined? What's 0 divided by 5? 0. What's 5 divided by 0? Nope. That's undefined. Division can give you an undefined result when we divide by 0. Okay. That's an oldie. That would have been from pre-algebra, right? What's another one? Would have been something used a lot last year when you dealt with quadratics. How about the square root? What's the square root of 9? 3. What's the square root of negative 9? Undefined. What kind of values give you undefined for square roots? Yeah, negatives. And then the last one you would have seen in your Algebra 2 class, but you guys didn't get very far last year. Is that the story? Okay. Did you guys get to logs? Okay. That would be the third one, so we'll just kind of leave that blank for now. We'll circle back to logs later. Well, I'll put it down anyways. Might as well write it down. Doesn't hurt nothing. Mostly because I want to point out and ask an interesting question here. Is there a difference between negatives and non-positives? Because Mr. Kulik used those two things. Do you think he just used synonyms, or is there a difference? There's a difference. Excellent. What is the difference? The non-positives have one more number in that group than the negatives do. 0 is neither positive or negative. So you can't take the log of a 0 either. But again, I won't assign you anything with a log in it because I know you haven't talked about them yet. So I just wanted to mention it. We should probably find some time to do a little bit with that. How many of us, do you guys have to take ACT still for college stuff? That'll be an ACT topic for sure. So if you have to take an ACT this year, it'd probably be nice to get there, right? Most of us are juniors, I think. Is that the deal? Okay. All right. So let's do some examples here. Find the domain. So my first function is f of x equals 2 times the square root of x minus 4. The first thing I'm going to ask, is there any division going on in this problem? No, man, there's no division in there, right? Everybody agree? Okay. Is there any square roots going on in there? Yes. So that part I definitely need to worry about. So what values can I take the square root of? Only the non-negatives. So the things I can take the square root of have to be greater than or equal to 0. Everybody's okay with that idea? So the thing underneath the square root must be greater than or equal to 0 for me to get something defined. So the only x's I can use are the things that satisfy that inequality. That'll be the entirety of my domain. Everybody feel good with that? So to get that x by itself, I'm just going to add 4 to both sides. Everybody's good with that? Just like I would solve an equation. I'll translate this onto a number line. So I have a filled circle at 4 because 4 is greater than or equal to 4. And then my arrow going to the right because that's where the things bigger than 4 live. So my lower bound on that interval is 4. My upper bound is positive infinity. Since 4 is included in my set, I'm going to use the bracket. The positive infinity always gets the parenthesis. And then to indicate that this is a domain, rather than just some arbitrary set, I'm going to say that X is a member of this set. That's equivalent to me indicating that I have a domain, or that this is my domain as opposed to like my range or some other set. Is that okay? We're going to do 2 more examples. Oh, and this here that we just did, this was our implied domain. The relevant domain is not applicable here because there's no context given to these variables. X and f of x are just symbols. They don't mean anything. Is that okay? All right. Now let's do another one. Okay, so the first thing I'm going to look for, is there any division going on? Yes. Why is there division going on? Where's the division happening? You're right. There's division going on here. Yeah, that's a fraction, right? The fraction is the same. A fraction is the same as division. So if we can't divide by 0, we know that that part in the denominator cannot be 0. And again, this is my implied domain that we're doing here. Everybody's okay with that? To solve for x, I'll just subtract 2 from both sides. And then I'll draw my number line. At -2, I'd get an open circle because 2 is certainly, or -2 is certainly equal to -2. The things that are not -2 are both to the left or to the right of -2. This looks exactly like the last interval notation example, doesn't it? So how would I write this? How would I write this? Who can tell me? Negative infinity. -2. Great. Anything else? Okay. Parentheses on both, you say? Okay. Anything else? The U. Very good. Keep going. Very good. Yep. Excellent. Perfect. So that's your interval. The last thing you do is put the x as a member of the set to indicate that we're talking about the domain, since the domain is about the x's. That's the story. Again, relevant domain not applicable because there's no context to the variables. Last example here for domains. So the last example here, we have V of S is equal to S cubed, where V of S is the volume of a cube with side length S. Here, we have some context, right? Everybody agree with that? I would still start with the implied domain. So if I look at just the equation part, is there any division going on? No. Is there any square roots going on? No. Is there any logs going on? No. So what would I say here? Just all real numbers. Just everything from negative infinity to positive infinity. It's going to have it all. Everybody's cool with that? Let's do the relevant domain now. Here we have to consider the context of the problem in addition. So the domain is about which variable, V of S or S? S, right? So S is representing a side length. What kind of numbers can represent a side length of a cube? Real numbers? Sure. All real numbers, though? Positive real numbers, right? You can't have a figure that has negative side length. That's bonkers. What the heck would that even mean? And I don't even know if you want to have zero side length. I would accept it either way if this was like a test or quiz question. If you wanted to count zero side length as like a nothing still as something, I think that's okay. If you didn't, that's okay. Oops. So we had say that we know S has to be greater than 0. You could also say greater than or equal to 0. I would mark either correct. Oh, okay. So 0, not included. Going to the right. So this is my relevant. I also need my implied here. The implied was everything, though, right? So my answer for my domain is going to be the overlap between the two. Now, this is really easy since the implied is everything. The overlap is just the same as the relevant domain. Everybody's okay with that? So just 0 to positive infinity. And notice here that I used S is a member of the set. Why did I write S there instead of X? In the equation was a function of S. Yeah, exactly right. I'm just using the same notation that the question used. Does that feel okay? So again, if you're looking for a domain from an equation, you're just checking to see if there's division going on, if there's a radical going on, or if there's a log going on. And then just taking the pieces and setting them either greater than or equal to 0 if it's a radical, not equal to 0 if it's division, or greater than 0 if it's a log. Not that you'll see any logs in your questions. I won't just assign you anything with logs right now because I know you don't know anything about them. It's okay. Doesn't mean I can't talk about them, though, and mention them. Now how about range then? Do you think range is going to be easier than the domain or harder? It's not. Unfortunately, it's not. The range is worse. I'm not going to ask you to do this algebraically, though, which is the place where it is worse. We're just going to do this kind of intuitively. So if I'm looking for the range, I would start by, I'm going to use the result from our domain, and then I'm going to also use my calculator. Everybody's okay with that plan? So I'm going to go find the range now for each of these three examples. Sound good? So I'm going to use my answer from the domain part along with my calculator. So I typed in my equation and did zoom standard because I had been monkeying around with my window all day. So if I look, the range is about the y coordinates, right? So I'm going to start by finding the lowest point on my graph, which looks like this point right here. Everybody agree with that? What's the y coordinate at that point? Appears to be 0, the y coordinate, not the x. Right? The y is the second component. It's the vertical. Everybody's good with that? And the highest point on my graph, well, it goes on like this forever, right? So it would be positive infinity. Everybody's okay with that? So the infinity obviously gets a parenthesis. What about the 0? That is going to get a bracket. How can I tell? Well, the symbol on that endpoint should match the symbol on the domain's same endpoint. Remember when we looked at our picture, this was the point 4, 0? Everybody agree with that? So if 4 was a member of the domain, it means that 4, 0 is a point on this function, which means that 0 has to be in the range as well. Is that okay with you guys? So I'm done. I'm just going to say y is a member of this. If I was trying to do this algebraically, that would be a pain in the tuchus, but we're not going to do that with you guys. Okay. Let's go look at the next one now. Everybody's okay? You'll stop me if you have a problem, right? Those are questions you could answer. Like, yeah, okay, I get it. I'll say something. It's okay. So let's look at our next example. So that was 2x over x plus 2. I know, we're all tired. I'm exhausted too. I was here till like 8:30 last night. Meet the parent. Yeah. I live an hour away. Grosse Point. There's 2 of us. Mrs. Sager. All right. All right. So here's my next piece. Notice something about this graph that's different than the other. What do you notice? There's 2 pieces of it. Very good. Exactly right. So I'm going to start with the lower piece first. We're going to do the range for that piece. And I'll do the upper piece second. We'll do the range for that piece separately. Everybody's okay with that plan? Looking at the lower piece, what's the lowest coordinate? Lowest y coordinate or smallest y coordinate? this going down forever? Negative infinity. Okay. Now let's look at this other end. That's the highest end. What do you notice about the line here? It's flattened out, right? That means that there's like an upper bound to that y coordinate, like it'll get no bigger than some value. If I look here, what value does that appear to be? That's 1, that's 2, looks like 2 to me. You guys buy that? If I'm just looking at counting, there's like y equals 1, that's y equals 2. If I track it across, it seems like that's the upper bound there. Now, should this get a parenthesis or a bracket? Parenthesis, because if I look at the domains bound, that was also a parenthesis. Now do my union. And now I'm going to look at the other upper piece here. So I'm going to, the shortest thing, well, it's also going to be at 2, right? Everybody agree with that? And the highest piece is, yeah, positive infinity, because this end is pointing whoop, all the way up. Everybody's okay there? We probably should say y is a member of. Okay, I did write that. Cool? Okay. Let's go down here. Now here we have to be a little bit careful, right? So if I type this into my calculator, I get this. But what is the domain for this? The relevant domain? 0 to positive infinity. So when x is 0, we're right here. That's the beginning of our graph, even though the calculator's got to show me the whole thing. I'm really starting here. The lower bound is 0. That's the shortest y coordinate, right? And the upper is positive infinity. And they're both parentheses because both ends were parentheses from before. All right, I think you guys could be able to do now 5 through 12 also. This will all be due, though, on next Sunday's problem set, not this Sunday's. Because I always want to give you guys a chance to ask questions before anything is due on a problem set. So, okay. We'll see you guys next week. Have a good weekend.